Today we will talk about valence shell electron pair repulsion theory, VSEPR. In today's visualization, you have to think of electron pairs as balloons. So imagine that we have some atom in the center here and we have electron pairs around it. VSEPR tells us that the electron pairs will try to get as far away from each other as possible, and so we can use these balloons to figure out what those shapes would be. So some atoms or molecules have two electron pairs around the center atom, and if we tie then two balloons together and look what shape those make, we can see that they make a straight line. They're right across from each other. 180-degree bond angle. However, if we take three pairs, three balloons, and tie them together, you can see that this is the arrangement that we get. I'm not making them into that. That's just kind of the natural lowest energy state that they can go into. So in this, you have, imagine that the atom is at the center. You have these are electron pairs around it, and you have 120-degree bond angles, and it's flat. This structure, that last one is called linear. This structure is called trigonal because it's got three sides, but planar because it's flat. Trigonal planar. If we then go ahead and throw a fourth pair on there, not easy to do. There we go. We can see that they take this sort of, it's almost like a tripod arrangement where you have each of the pairs is sort of, if you look at these real closely, these balloons are not flat, they're pointing down a little bit. Down, 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 just a little bit, and this one's going straight up over the top. This is called a tetrahedral, named so because it has four faces. Tetra, four, hedra, face, faces, I guess. Tetrahedron is the singular. So you have one face, you have like a, think of it kind of like a pyramid. I don't want to say that too much because there are other things we call pyramids. This is a tetrahedron, but you have four faces. You have a face here, 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 and on the bottom. The bond angle here is bond angles here are not easy to necessarily visualize, but you can tell that they're more than 90 degrees, but not as much as 120. It turns out that the number is 109.5, and so those are the basic arrangements for electron pairs around the central atom in Chem 1 for 2, 3, and 4 pairs. Thanks and have a nice day.